So today I'll be showing you guys how to conduct a one-way ANOVA test. So as you guys can see, I've kind of already set up. I have my table here that we're gonna fill out. I have the means of our groups, and it's just nice to have them here because we're gonna need these in order to figure out these over here. And then I have our distribution here. Because we're gonna find our F critical and we're gonna find our F statistic. And then right here I have our groups. We have 3 groups, Group A, Group B, and Group C. Each group has 5 data points that I got by using the random number generator from Excel. So that's our data. And then this is our null and alternative hypothesis. So our null hypothesis is saying that mu A is equal to mu beta equal to mu C. So it's saying that they are all the same, that there is no difference between the means of these groups. And then the alternative hypothesis is saying that not all mu are the same. There's at least one of them is different. So that's what we're working with today. So just to start us off, we can start off by getting our degrees of freedom in order to get our F critical. So I already wrote down our formulas for these. And so in order to find the total degrees of freedom, we do n minus 1. And so our n is 15. Because we have 3 groups and each group has 5, so 3 times 5 is 15, so that's our n. And so our degrees of freedom total would be n minus 1. So 15 minus 1 would be 14. So we already have our degrees of freedom total. And then we can solve for degrees of freedom in between, which is the number of groups minus 1. So we have 3 groups, so 3 minus 1 would be 2. And then we can figure out our degrees of freedom within by just doing the math. So this degrees of freedom within would be 12, because 2 plus 12 equals 14, or 14 minus 2 equals 12. So we have our degrees of freedom. And now what we can do with that is that we can find our F critical using our F table. So we're going to use these 2 numbers, and I have my F table pulled up here. I'm not sure if you guys can see it. I can try to show it. This is our F table, and basically what we're going to do is up here we have 2 degrees of freedom. So we have our 2 right here, and then this is our degrees of freedom between, so 2, and then we're gonna go down until we find our degrees of freedom within, which was 12. So 12 and 2 equals 3.8853. So our F critical, right here is, let me make sure that I'm 3.8853. Perfect. 3.8853. So that's our F critical. Okay, so moving on, we have to get the mean for all our groups. So in order to do that, we have to add up all our data points from each group and then divide them by how many data points there are. So if we look at group A right here, we have 95 plus 16 plus 7 plus 9 plus 24 gives us a sum. And I'm gonna write the sum here just because it's gonna help us later on. It's gonna make stuff a lot easier. So we have 151, the sum of group A, 151, divided by 5 equals 30.2. So the mean for group A is 30.2. And so we're just gonna do this for Group B and Group C. We're gonna do the same thing. So 97 plus 17 plus 70 plus 40 plus 82, 306. We're gonna write the sum, and then we're gonna divide it by 5. So 61.2. And then lastly, Group C, 77 plus 47 plus 84 plus 8 plus 4. That equals 220 divided by 5. That equals 44. So now we have the means for each one of our groups. And so now we have to find our grand mean. And in order to find our grand mean, we have to sum up all the data points. So we have to sum up all the data points from Group A plus all the data points from Group B and all the data points from Group C, which is why I wrote the sums. It's just a lot easier writing the total sums already. So, and then what we do is we divide it by the data points, how many data points. So we're gonna sum up all our numbers, and we're gonna divide it by how many data points we have. So we're gonna do 151, which was the sum of Group A, plus 306, which is the sum of Group B, plus 220, which is the sum of Group C. We're gonna add those up together, and we got 677. And then we're gonna divide them by how many data points we had. So remember, like I said, we have 3 groups, and each group has 5 data points. So that means that there's 15 data points in total. So we're gonna divide 677 divided by 15 is 45.133. So that's our grand. So now that we've gotten all our means, we can move on to the next step, which is calculating our sums of squares between. And the formula for that, and I'm just gonna erase this right here because we don't need it anymore, just so I can have a little bit more space. So the formula for the sum of squares between, and I'm gonna try to write this as small as possible just because I'm gonna need a lot more space to make calculations. So it's the sum of NG times the X bar of a given group minus the grand mean. So this is our formula for the sums of squares between. So what that would look like if we plug in our numbers, that would be 5, because remember that's how many data points each group has. We have 5 data points in each group, so that would be 5 times, and we can start with Group A. So the X bar for Group A was 30.2 minus our grand mean of 45.133 squared. And then we're gonna add our next group. So 5, and now we have the mean of Group B, which was 61.2 minus the grand mean, 45.133 squared, plus, again, 5, and then 44, which was our X bar for Group C, minus 45.133 squared. Okay, and now we have to solve for these. So I'm gonna use my calculator just because I'm not good at like quick math stuff in my head. So we're gonna do just step by step, just to make it easier. So we're gonna do 30.2 minus 45.133. That's negative 14.933 squared plus, now we're gonna do the same thing. We're gonna do 61 minus 45.133, and that is 15.867. Let's square that. So, and then the next one is 44 minus 45.133. Oh, sorry, 44 minus 45.133. And that would be negative 1.133. Okay, and so then we continue. And now we can square these numbers, so we can do negative 14.933 squared. So that's 5 times 122.9 plus 5, and then we can do 15.867 squared. That's 251.761 plus, and we have negative 1.133 squared, and that gives us positive 1.283. Perfect. And now we're just gonna time those. So we have 5 times 222.9. That gives us 5 plus 5, 251.761 gives us, these are big numbers, 1,058.80 plus we have 1.283. Our smallest number, 6.415. And so now we just have to add these numbers together. So we have 4.5 plus 1258.80 plus 6.415. That gives us 2,379.715. Okay, so that's our sum squares between, so we can just gonna go ahead and write that right here. So you have 2,379. Okay, perfect. So we already got our sum of squares between. And then now we can solve for our mean square in between, which is just this number divided by 2. And so we'll just, you know what, I'm gonna take a quick picture just because I'm gonna have to erase this and just make sure that we have our work. So I'm just gonna picture really quick. Okay, so like I was saying, our mean square, we can just get it by dividing our sum of squares between. So we do 2,379.7 divided by 2, and that gives us our mean square. So we're gonna do that really quick. we do 2,379.7 divided by 2. That gives us 1,109.80. Okay, so then the next part to this process is to calculate our sum of squares total. And in order to calculate our sum of square total, we have to, for every single data point, we have to subtract the grand mean and square it. So that's, since we're doing this by hand, it's gonna take a little bit more time, so just bear with me. But we're gonna do this by parts. So I'm just gonna go ahead and erase this. I already have my picture, we already have our numbers, so we should be okay. Just gonna erase that just so we can have more space to do this. Okay. Okay, so that our formula for SST is the sum of each individual data point minus grand mean squared. So that's the formula. So we're gonna do this by parts. We're gonna start with group A. Just gonna put it here, and we're gonna do this for everyone in group A. So we're gonna do 95 minus 45.133 squared plus 16 minus 45.133 squared plus 7 minus 45.133 squared plus 9 minus 45.133 squared. And we're gonna try to squeeze it in here just because it'll be nice to like have them all together, and then we can just keep going from there. So we have our last number, which is 24 minus 45.133 squared. Okay, so now I'm just gonna solve this, and just so I can go a little bit faster, I'm just gonna do it on my calculator. Instead of subtracting it, writing the number, and then squaring, I'll just do it all completely. So we're gonna do 95 minus 45.133 minus 45.133, and we're just gonna square it already. It gives us 2,486.7, and then plus the next one, 16 minus 45.133 squared, that's 848.73. Okay, 0.73, and then we have 7 minus 45.133. Oh, 7 minus 45.133 squared. That's 454.125. We'll just go to digits. Perfect. And then our last one is 9. Not our last one, I'm sorry, our second to last. 9 minus 45.133 squared, which is 1,305.59. And then our last one is 24 minus 45.133 squared is 146.60. And so now we're just gonna add all these numbers, and then I'm just gonna write them here, what they are, because then we're gonna have to, whatever we get for here, we're gonna have to add them up, just because we're doing this by parts. You know, instead of doing it all together, I have to do it by parts, just because there's not enough room. So I'm just gonna have to write our answer here, and then add them all up when later. So we have 2,486.7 plus 848.73 plus 1,454.12 plus 1,305.59 plus 446.60. That gives us 6,541.74. Okay, so I'm just gonna write this here just so we don't forget. 6,541.74. And now we move on to the second group. Gonna move on to group B. Okay, and we're just gonna repeat this process again. So we're going to do 97 minus 45.133 squared. I'm just going to try to go a little bit faster. 17 minus 45.133 squared plus 70 minus 45 plus 133 squared plus 40 minus 45.133 squared plus 82 minus 45.133 squared. So we're going to do the math again. So we're going to do 97 minus 45.133 squared. That gives us 2,690.18. Oh, and my marker's running out. 17 minus 45.133 squared is 791.46. Can't really see those numbers. And we have 70 minus 45.133 squared gives us 618.36 plus 40 minus 45.133 squared gives us 26.347 plus 82 minus 45.133 squared gives us 1,359.17. And so now we're just gonna add up all these numbers. So 2690.18 plus 791.46 plus 618.36 plus 26.34 plus 1,359.17. That gives us right here, and I'm just gonna write it right here, right under what we got for A, 5,485.51. And so now we're gonna repeat this process again with group C. And it's getting a little messy. I want you guys to see, so I'm just gonna try to make it a little bit better. Probably not gonna do much because these are kind of old and kind of worn out, but we'll work with it. Okay, perfect. Well, not perfect, but okay, so next, like I said, we're going to repeat this process with group C. So group C, it goes 77 minus 45.133 squared plus 47 minus 45.133 squared plus 84 minus 45.133 squared plus 8 minus 45.133 squared plus 4 minus 45.133 squared. And so we're just gonna do that again really quick. 77 minus 45.133 squared gives us 1015.0. And so we do 47 minus 45.133 squared. That is 348 plus we have 84 minus 45.133 squared gives us 1510.64 plus 8 minus 45.133 squared gives us 1378.86 plus 4 minus 45.133 squared. 1091.92. And so now we're just gonna add up all those numbers up. So 1015.50 plus 3.48 plus 1510.64 plus 1378.86 plus 1691.92 equals, so C equals 5,604. Okay, perfect. And so now all that we have to do, all that is left to do in order to get our sums of squares total is to add up all three of our numbers. So we're gonna add them up, and that's 6,541.74 plus 5,485.51 plus 5,600.4 equals, so our sum squared equals 17,627.65. So that's our sum squares total. So we're just gonna put that 17,627.65. And so now what we can do, we can just do a little bit of math, and to get our sums of squares within, we can just do 17,627.65 minus our between, which was 2,379.7, and that gives us our within, which is 15,247.9. Since we now have our sums of squares within, we can go ahead and calculate our mean squares within, and we just do that by getting the number, so like 15,247.95. So the number we just got for our sum of squares within we divided by our degrees of freedom, or within degrees of freedom. So that would be divided by 12, and that would give us our mean square, which would be 1,270.62. And now since we have both our mean squares, our mean square within and our means of squares between, we can go ahead and divide these two, and that'll give us our F statistic. So we do 1,809.85 divided by, so 1,189.85 divided by 1,240.62, and that gives us 0.959. Okay, so if we look at our distribution here, we have our F critical, and then we have our F statistic of 0.959. So that means if this is 1, our F statistic is somewhere here. Because we got an F statistic of 0.959, we fail to reject our null. There is not enough evidence to suggest a significant difference between the means of Group A, Group B, and Group C. Thank you.